In this video, we evaluate this integral, this intimidating looking integral. So if you look on the right hand side, the answer to this integral is on the right hand side, right here. So you may want to try this integral before following the steps in the video. So I'm going to break this integral step by step for us to understand. So what I'm going to do, I'm going to start off by dividing the numerator and the denominator of this integral by x squared. So I'm going to divide the numerator by x squared, and I'm going to do the same thing to the denominator. So I'm just going to write the denominator, and then I'm going to divide this one by x squared as well to maintain equality, right? So if I do that, then I'll have the integral of x squared over x squared is 1 minus 1 over x squared. That is the numerator, and the denominator, we are going to divide x raised to the power 4 over x squared, which is x squared, plus 3x squared over x squared, which is 3 plus 1 over x squared, and then multiplied by the tan inverse of x plus 1 over x. I'm sorry about this, plus 1 over x, and then dx here. Right, so let's do some simplification. So we have the integral of 1 minus 1 over x squared divided by this one. I can write that one as x plus 1 over x, right, all squared. If we have x plus 1 over x all squared, this one can be foiled by, you have x squared plus x times 1 over x times 2 is 2 plus 1 over x squared, which is 1 over x squared. But this is not the same as our original integral. This is 3, but this is 2. So what you have to do is just to add 1 to this expansion. So when you add 1 to this, then this one is going to be 3. So this one here can be expanded as x plus 1 over x squared plus 1. And all this is multiplied by the tan inverse of x plus 1 over x. Dx. Cool result. So I am now going to clean this one up. Okay, so we are now going to do a u sub, right? We are going to let u to be equal to x plus 1 over x. So doing that, if we are differentiating du dx, this is going to be equal to 1 minus 1 over x squared. That is a differential of 1 over x. And then we have du to be equal to 1 minus 1 over x squared, all this one dx. That is what we have. So in place of 1 minus 1 over x squared dx, I'm going to replace that with du. So this one here times dx, this one can be replaced with du. So have I to be equal to the integral of du all over, this is u from our u sub, so that is u squared plus 1 multiplied by tan inverse of x plus 1 over u. 1 over x is u. So this is what we have, the integral of 1 all over 1 plus u squared multiplied by the tan inverse of u du. So we are going to do another u sub again. So we are going to let k this time to be equal to the tan inverse of u. So when we do that, the k is going to be equal to differentiating tan inverse of u is 1 over 1 plus u squared du. So I'm going to rearrange this integral. So rearranging that integral, you have I to be equal to the integral of 1 all over the tan inverse of u multiplied by 1 all over 1 plus u squared, and then du. So that means in place of 1 all over 1 plus u squared du, I'm going to replace that with dk. So the integral in the k world is now the integral of 1 all over tan inverse of u is k times 1 all over 1 plus u squared du is dk. And now integrating this is trivial. This is just equal to the ln of the absolute value of k plus the constant of integration. Now we have to move back into the x world because the original integral was in terms of x, right? So I is going to be equal to the ln of k. K is tan inverse of u. So ln of the absolute value of the tan inverse of u plus the constant of integration. But what is u in terms of x? we are going back into our x value using this expression. That's the first substitution. U is x plus 1 over x. So I here, our integral is ln of the tan inverse of x plus 1 over x plus the constant of integration. So this is the answer to our integral. So when we come back here, we can see that that conforms with the answer that I gave in the beginning of the video. So the answer to this integral is the ln of the absolute value of the tan inverse of x plus 1 over x plus the constant of integration. So it may look intimidating, but doing the right division and using the right substitution, this integral is completely flipped on its head. So that is how I can solve this integral. If you have an easier way of solving this, please leave a comment in the comment section and let me know what you think. I thank you so much for watching this video. Please subscribe to Calculus Diaries for more engaging content on integrals. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.